We're looking at a ring and a chain. Which is the parent system? We've seen a lot of parent chains so far, but we must consider the ring. There are 5 carbons that are contiguous in the chain. But in the ring, there are 6 carbons. The ring is the parent system. 6 carbons, hexane. But it's a ring, so that's cyclohexane. Next, we need to describe the location of the functional group on the main ring. In this case, it's easy. There must be one of the functional groups at position 1. We have only one functional group, so guess what? It's at position 1. Okay, now for the trickier part. We have another complex alkane, and this one's even more complex. We need to view it as its own individual molecule. We need to identify the sub-parent chain. We have 5 contiguous carbons here. So it's a pentane. Because it's the functional group of another main ring, it's going to be called pentyl. Now, we need to identify the location of its functional groups. We have an ethyl group at position 2 and a methyl group at position 3. Notice position 1 is attached to the main ring. So we have 2 ethyl, 3 methyl, pentyl. The final name for this molecule is 2 ethyl, 3 methyl, pentyl, cyclohexane. Notice that we haven't indicated the location of the complex alkane at position 1. This is because there is only one functional group, and so it must be at position 1. We don't have to tell you that. Okay, so we've seen when we're dealing with rings and chains, it's a simple question of which has the more contiguous carbons. That will be the parent system. But if the ring and the chain both have the same number of contiguous carbons, well, you've got a draw. But the rule says the ring will be the parent system.